little bit cut. So I just want to add two final things, okay? The first one is that the number of hydrocyclones, this model doesn't have enough capacity, okay, for the 350 cubic meters per hour of slurry. So we divide the total flow rate over the flow rate that can be supported by this hydrocyclone. This gives us 1.6. We always have to approximate to the largest following integer, which in this case would be 2. So we require 2 hydrocyclones model, this model over here. Now, there is a little something that I have to add, sort of like a federatas to the first exercise. So I'm just going to go back a little bit. Okay, so everything up to here was okay, except for the fact that I have to add one final formula to this procedure. The final formula is the following: that the final diameter of the hydrocyclone diameter is going to be calculated as the D50 that we already calculated, okay? This D50 over here that we already calculated, okay? This number is going to be divided by 2.84, which is just an empirical number, okay? So don't get scared with that. Okay, this is just an empirical formula. And all of this elevated to to the power of 1.51. Okay, all of these are empirical formulas, remember. Okay, so in this case, if we apply this, the final diameter, or the actual diameter, is going to be, wait a second. I know I say wait a second, you guys are not going anywhere. Okay, so now I'm back with the calculator. So this number would be, just put this down over here, 42.1 divided by 2.84, and all of that to the power of 1.51. Okay, and that result is, it's probably going to give us the same result as before. I don't think this is going to be higher than 20 inches anyway. So this is 42.1 divided by 2.84, and all of that to the power of 1.51. And this is 58 centimeters. And that divided by 54 is 23 inches. Okay, great. So I have to do this all over again. So this is 23 inches, okay? Now, the model that we previously selected, okay, this one's no good anymore because this is for a 20-inch hydrocyclone. So now we have to move to the next size, which would be this one over here, okay? And well, this one has a kind of like a smaller range, and we're sort of like within the limits of, or at the border of our maximum capacity, because this is like 360 cubic meters per hour. So we would actually require just one. So new calculations, model blah blah, 650 CV times or just X, and that's a 26 diameter or inch diameter one. And in this case, we would just require one, or maybe two actually, because it's 360, but 350 falls within the range. So we just need one model of this hydrocyclone. Okay. So I hope we cleared that up. Just in summary, remember that there's a final formula here that you have to work through, and this is going to give you the final hydrocyclone diameter. So this is the one that you have to work with, okay? Just so we're clear on that.